CSEC multiple choice practice paper 7 a little further with the third portion of 15 problems. This one will take us from problem number 31 through to problem number 45. According to what we have right there for that algebraic expression, all that is required in solving this problem is for us to expand the brackets and combine the like terms. We will begin by expanding the brackets. Put that under the microscope. We say 3a multiplied by a, and that will give us 3a squared. Then 3a multiplied by 2b will give us 6ab. Continuing, we take negative b multiplied by 2a, we get negative 2ab, and negative multiplied by negative is positive, so a positive 3, no doubt, b multiplied by b is b squared, and that is what we have right there. Let us combine the like terms, if any, and there we have two like terms. So the like terms are a positive 6ab and a negative 2ab. In combining like terms, we add the coefficients. Adding a negative 2 with a positive 6, the result is a positive 4. So that middle term, single middle term, that is as a result of combining those two like terms, will be a positive 4ab. No more like terms. The unique terms will be included as they are. So we have some unique terms there. They are the 3a squared and the 3b squared. The correct answer is option B. For those candidates who are on top of their algebra, they may think that the problem is very simple. However, I see that some candidates will be found wanting if they do not apply the distributive law properly, especially the consideration of the results of multiplying positive and negative numbers. So in this particular problem, we need to consider the distributive law. That is one serious thing that we need to consider, and also the result of adding or subtracting, and we have the multiplication of directed numbers, positive and negative numbers. If we are sharp on those two, the combination of positive and negative numbers and also the distributive law, then the solution of this problem may not be so elusive after all. If f of x is equal to x squared minus x minus 1, then f of negative 5 is equal to... This problem requires that we evaluate a function f of x for a particular value of x. In order to solve this problem, one good initial move is to create a template that looks like the function. Template should look like this. So there we have the template. F of something, right there, something squared there, negative something right there, and negative 1 not to be left out. X is squared, therefore we leave a slot for it. Leave a slot for x squared. Then what do we know? Next, we need to subtract x. The slot is also made available for it. Let us insert the value of x, which is equal to negative 5, into each slot. So we are evaluating the function for x is equal to 5. So in those slots, we put negative 5. X is equal to negative 5. The square of any number is positive. The square of negative 5 is therefore a positive 25. What do we have here? Consecutive negative signs. The negative of a negative number is positive. We may also treat it the same way as the multiplication of a number by negative 1. So the negative of a number, which is the negative of a negative number, is positive. And we may treat this as we would treat negative 5 multiplied by a negative 1. Negative 5 multiplied by negative 1 is positive 5. We'll go there. And finally, the negative 1 is not to be left out. 25 plus 5 is 30. Minus 1 is 29. And that is our answer. That is option B. By using the template, there are a few errors that may be trapped and eliminated. Negative 5 is placed in the brackets and squared. This demonstrates that the entire negative 5 is squared and not only the 5. There is a negative sign, that is the first one. By enclosing the entire negative 5 inside of this bracket, we are sure that it is the entire negative 5 that we are squaring and not just the 5. There is a negative sign preceding the second bracket. Second pair of brackets, there's a negative sign that precedes this one. When negative 5 is inserted, the double negative is clearly seen, as we have it clearly seen right here. In haste, a candidate may just use a single negative sign. It is not impossible to solve the problem without a template and get it right. The inclusion of the template just makes it more likely. And no doubt, if we did not put a positive 5 here but a negative, we would have 25 minus 5 minus 1. So it will be 25 minus 5 minus 1. Which of the following represents the equation of a straight line? The equation of a straight line has the general form that we have right there. Y is equal to mx plus c, in which m is a gradient and c is the y-intercept. So that is the general form of the equation of a straight line. The equation in the options that has the same form is the equation of a straight line. So we have highlighted here the word form. Not the same as, but the same form as. So the one that has the same form as this is the equation of a straight line. The one whose form matches the general form of the equation of a straight line is option B. So we are identifying that right away. Some candidates are blinded or may be blinded by the fact that we have a negative sign here while we have a positive sign here. Do not forget that these signs, if we are doing directed numbers, may be treated also as a plus sign, but we are adding in the negative direction. Or we may say we are adding by saying we are adding with a plus sign, so we are adding a negative 3. So that is another way of looking at it. So the negative sign that we have here is not something that prevents this equation from being in this form. So let us take a look at the first one in the option y is equal to 4 over x compared with y is equal to mx plus c. The form of A, or the one that is in option A, does not match because it has a single term. Furthermore, x is in the denominator of a fraction. So that is not the equation of a straight line. Not going to have x in the denominator of a fraction. What about that one? The form of option C does not match because of the x squared on the right hand side. When we have x squared here, this is not the equation of a straight line anymore. This x squared prevents it from being the equation of a straight line. Make another comparison. Option D has a square on the left hand side. It does not match. So option D has a square on the left hand side. So it does not match. So this option does not match the equation of a straight line. So this y squared prevents it from being the equation of a straight line. In the general form of the equation of a straight line, m and c are real numbers. M is the gradient and c is the y-intercept. That is where the line crosses the y-axis. The arrow diagram shows a function. Which of the following best describes the function? That is, which one of these options best describes this function? The first expression is obviously correct. The function is operating on x by adding 3 to x in order to give the value of y, and that we'll look at by the time that we are finished with this slide. So the correct answer is A. The second statement cannot be correct. According to the direction of the arrows, which is from x to y, the function is not operating on y. Neither can there be a function of x with y in its algebraic representation. So we have f of x is equal to y plus 3. The function is not operating on y, therefore we should not have y here. This statement of option C cannot be correct because there is no single case in which we add 3 to the value of y and the result is equal to the value of x. So we have x is equal to y plus 3. This is the value of y, which is 5. If we add 3 to 5, we do not get 2. So x is not equal to y plus 3. We may say that we could check the others. As a matter of fact, we should not have to check the others, because if it is true, it is going to be true in every single case. Y is equal to x. D cannot be correct because there is not a single case in which the values of y and x are equal. So D cannot be correct. This says y is equal to x. Is there any case in which y is equal to x? No. Further, if we had y equal to x in all cases with the exception of one, then this statement still would not be a statement of the mapping that we have right there. So it would have to be true in every single case. And we have it not being true in any single case at all. Therefore, we are sure that the expression that we have here is not an expression of this function that we have over here. We may go ahead and verify that option A is correct. Add 3 to each value of x and the result is the corresponding value of y. 2 plus 3 is equal to 5. 5 plus 3 is equal to 8. 8 plus 3 is equal to 11. And 11 plus 3 is equal to 14. There we have it. In every single case, when we add 3 to the value of x, the result is the value of y. So option A is correct. F of x is equal to x plus 3. From the graph, the value of x where y is equal to 0 are, so it should be the values of x where y is equal to 0. What are those values of x where y is equal to 0? The values of x where f of x is equal to 0 are the points where f of x crosses the x-axis. So, at the point where this curve crosses, are the points, because we have more than one of them, this one right here and this one, those values are the values of x when y or f of x is equal to 0. So x is equal to negative 1.75 and positive 1.75. The correct answer is option D. At first glance, the answers may appear to be negative 1.5 and positive 1.5. But what do we know? However, the answers are halfway between 1.5 and 2. And on the negative side, we have between negative 1.5 and negative 2, halfway between those. As a matter of fact, right here would be negative 1.5, but it is here, halfway between negative 1.5 and negative 2, which is actually negative 1.75, and that is analogous to what we have on this side. What is the gradient of the straight line that we have right there? The equation of a straight line has the general form that we have seen on a previous slide. Y is equal to mx plus c. In that general form, m is the gradient. Therefore, if we have an equation of a straight line written in that general form, the gradient is readily identified as the coefficient of x. So in this general form, the coefficient of x is m, which is the gradient. Therefore, if we write this equation in the general form, the result that we have right there for the coefficient of x will turn out to be the gradient of the straight line. The equation in its present state is not in the general form. We need to write it with y alone on the left hand side. This may be done by using the transposition of formula method, dividing through by 2, thereby eliminating 2 from the left hand side, because we have what? Y is equal to mx plus c. Here we have 2y is equal to. So we just need y. We will achieve that by dividing by 2 on the left hand side. Then, consequently, in order to balance the equation, we will divide on the right hand side by 2 also. We may say that in short as dividing through the entire equation by 2. We divide each term on the right hand side by 2 in order that the equation may more closely resemble the general form. So divide each term by 2. We are dividing the entire thing by 2. That is equivalent to dividing each term by 2. And we are doing that in order that the right hand side may more closely resemble the general form. So we have y is equal to negative 3x over 2 and negative 3 over 2. Again, we may put the x right there. We have 3x over 2 may be written as what? 3 over 2x. So there we have highlighted the coefficient of x. Now that the equation is in the general form, we may readily identify the gradient m as the coefficient of x. The correct answer is option B, negative 3 over 2. We did not have to transpose the equation, writing it in the general form of the equation of a straight line in order to identify the gradient. We know that we need to divide by 2. We could have done it mentally instead of writing it down. So we know that we would have to divide this -3 that we have here, or the entire thing. If we divide the entire thing by -2, it follows that we would have to divide also -3 by 2. So dividing that by 2, we could have seen that the gradient would turn out to be -3 over 2, and that we could have done without going through the entire process. Which of the following does not represent a function? So which of the following does not represent a function? We will first apply the test that qualifies a graph as a function in order to identify the one that is not a function. Then, on another slide, we take a look at the reason for it. Let us make use of the vertical line test that states that if a vertical line can cross a graph more than once, then it is not a function. So if the vertical line can cross it more than once, then it is not a function. So we may place a vertical line on the graph A and show that whatever its position, it will not be able to cross it more than once. So put that vertical line there. We see that the line is crossing at each point only once. So the line is crossing this graph only once. So we see that this line is crossing this graph at only one point at any single time. That means that one is a function. Because the line is only able to cross it once, we are sure that it represents a function. Do the same with graph B. We see that it is crossing all the time at only one point. We are sure that graph B also represents a function. The vertical line can cross it only once. It is a function. What about that one? We notice that if we start, let us stop it right here. The line is crossing here and here, crossing it at 2 places. So we are sure that that one is not a function. We can already see that graph C has 2 intersections with the vertical line. It is not a function. So graph C is in contact with the vertical line at 2 points. It is therefore not a function. Option C is the correct answer to the question, which of the following does not represent a function? So this one does not represent a function because the vertical line crosses it more than once. It should not be a complete necessity to apply the rule to graph D. We can see without placing the line on it that it represents a function. Besides, we have already concluded that C is the correct answer. That is, the one that is not representing a function. However, we have the time and space for it, so let us go straight ahead. Putting the vertical line on it, crossing it once. All the time, it crosses the graph only once. So we are sure that C is our correct answer. D also is a graph that represents a function. We can see that throughout the entire trajectory of the vertical line, it is in contact with only one point of the graph at a time. D also represents a function because the vertical line can only cross it once. Students sometimes mistakenly include the axes as a part of the graph when attempting to determine how many times the vertical line should cross the graph. They are there, that is, the axes are there to define the system of coordinates on which the graph is formed and is not a part of the graph itself. Let us take a look at the reason why if a vertical line crosses a graph at more than one place, then the graph is not a function. Here we have our graph. There is your graph for problem number 37. Throw in a vertical line. There it is. As discussed before, the vertical line is crossing it at 2 points. Let us label those points with 2 general coordinates. There we have them. The 2 points are vertically aligned. They will therefore have the same x-ordinate. As we can also see, there is some disparity between the 2 y-ordinates, making them different in values. What are the consequences? The line is vertical. On a vertical line, the x value is the same every place on this line. Therefore, whatever we have for the x value here, it is the same thing that we need to have here. So there is no difference in x value between this point and this point. So if this one is x1, so is this one. However, we can see that there is some difference between these 2 points. Therefore, the y values are different. So if we should represent this situation by a mapping from the set of x values, the domain, to the set of y values, the codomain, the set of x values will have one element. So the set of x values will have one element. Only one value for the x. But what do we know? 2 values for the y. The 2 elements will have 2 images as suggested by the vertical line of association. So there we have x1 going to y1 and y2. According to the definition of a function, an element in the domain can have only one image in the codomain. For the resulting mapping, there is a violation of that law. The single element x1 has 2 images y1 and y2. The mapping does not represent a function. That is why when a vertical line crosses a graph at more places than one, it does not represent a function. Because if it crosses at more places than one, we will have one x value being associated with 2 y values. And that will prevent it because we are mapping from the set of x values to the set of y values. A cylindrical bar of soap 5 centimeters thick has a volume of 200 centimeters cubed. A uniform slice 3 centimeters thick was taken away. What volume of the soap remains? Let us go all the way around and see if we can determine the answer. Let us draw a representation of the cylindrical bar of soap. There we have it. It is 5 centimeters thick. Let us show where a slice 3 centimeters thick may be cut off. So, a slice 3 centimeters thick may be cut off from there. The soap is cylindrical and is therefore of uniform circular cross section. Therefore, the volume of the soap cut off and that which remains will be affected by the thickness only. So, we have this cylinder and we are sure that it has uniform cross-section. Therefore, whatever the cross-section here is, it is the same cross-section here. If we cut it or cut a slice from it right here, the cross-section that is here, the cross-section of what remains, and that which is removed, those cross-sections will be of the same area. Therefore, the portion or the fraction of the bar of soap which is taken off and that which remains is only affected by the thickness. So the fraction which remains and the fraction taken away, those are only affected by the thickness. The thickness of the soap that remains is 5 minus 3, which is equal to 2 centimeters. So the thickness is 2 centimeters that remains, and we have 3 centimeters removed. The thickness of the soap that remains may be written as a fraction of the entire bar. The thickness of the soap that remains may be written as a fraction of the entire bar. 2 centimeters remains out of 5 centimeters. So 2 out of 5. 2 of 5, 2 out of 5 of the entire volume. That fraction will be multiplied by the volume of the entire bar of soap. Therefore, what do we know? The result is 80 centimeters cubed. So that is the volume of the bar of soap that remains. The correct answer is option A. We did not consider the cross-sectional area because it is the same throughout the prism. This does not make it insignificant in determining the volume. On the next slide, we will consider the cross-sectional area and use it to get the correct answer. Now, the approach that we have taken here is on the basis that since the cross-sectional area is the same throughout, it will have no bearing on the fraction of the soap that remains or the fraction that is taken away. Therefore, we did not consider the cross-sectional area in solving the problem. However, if we consider the cross-sectional area, the answer would have been the same. So the volume of any prism is given by V is equal to the area times the length, or the area times the thickness. A is the cross-sectional area and L is the length. In this particular case, the length is the same as the thickness. Let us replace the length with the thickness. So volume is equal to the area times the thickness. We have the volume and the thickness. Let us substitute them into the expression and find the cross-sectional area. So the volume is 200 centimeters cubed and the thickness is 5 centimeters. A is multiplied by 5. Divide the right hand side by 5 and we have the cross-sectional area. But we need to do that to the left side also. Dividing both sides by 5, we get area is equal to 200 divided by 5, which is equal to 40 centimeters squared. When we subtract 3 centimeters from 5 centimeters, we have 2 centimeters left. Since the cross-sectional area is the same throughout, we will take the cross-sectional area and multiply by the thickness of the soap that remains. So we have the cross-sectional area multiplied by the thickness of the soap that remains, and the answer is the same as we got before, which is 80 centimeters cubed. Whether or not we consider the cross-sectional area, the answer turned out to be the same. It is for us to understand that the cross-sectional area is a constant throughout the entire bar of soap, which is a prism. Or it is a cylindrical bar of soap, and a cylinder is a prism with a circular cross-section. So the volume that remains may be shown to depend on the thickness as long as the cross-sectional area is preserved. And we are sure that the cross-sectional area will be preserved because we are talking about the volume of a prism, and a prism has a uniform cross-sectional area. The diagram shows a line PQ. The gradient of the line PQ is what we are attempting to find. And there we have the general representation, or a general representation of the gradient of a line determined by using the coordinates of 2 points through which the line passes. The gradient of a line that passes through 2 points x1, y1 and x2, y2 is generally given by m is given generally as y2 minus y1 over x2 minus x1. A candidate will still be correct if he uses m is equal to y1 minus y2 over x1 minus x2. Irrespective of the points that you label x1, y1 and x2, y2, if both of the formulae, which are essentially the same, are applied, then only one of the results should match an answer in the option, since we can only have one correct answer. Okay, so only one of the results should match an answer in the option, irrespective of what we do, as long as we are attempting to solve the problem and we are using a mathematically legitimate method. Then irrespective of what we do, only one should match an answer in the option, since we can only have one correct answer. So let us label x1, y1, x2, y2, but it doesn't matter which one we label, because irrespective of what we do, if we are correct, only one can match the correct answer. So application of the first formula, we give m is equal to, application of the first formula will give m is equal to d minus b over c minus a. So y2d minus y1b, so d minus b over x2c minus x1a, c minus a. There we have it. Here we have c minus a, but we do not have b minus d. Right here we have d minus b. That is not correct. The second one will give y1b minus y2d, b minus d, over x1a minus x2c. There we have it. The correct answer is option D. The examiners know that some candidates may exercise a bit of narrow-mindedness or lack of knowledge and may not move to the other expression, reversing the order of the differences. Therefore, the examiners may be saying, well, if the candidates are narrow-minded or they lack in knowledge, they may just apply this one, getting this result. Maybe they will say that the option is not there, or since we have d minus b somewhere, let us see if we have it. No. But do we have c minus a? Yes, we have c minus a right here. So they say, okay, then we have a part of it right. C minus a, option A is correct. But we need to recognize that if we reverse both differences, then the result is the same, and that we will demonstrate on the next slide. So take a look at the expression that we have for the possible gradient of a line. So take a look at the expression that we have for the possible gradient of a line. 4 minus 9 over 5 minus 2. On simplification, we get m is equal to negative 5 over 3, which may be written as negative of 5 over 3. If the numbers were reversed, reversing the differences, the result would have been the same. So we would have had 9 minus 4 over 2 minus 5. Simplifying the answer, we get 5 over negative 3. But what do we know? Positive divided by negative is still negative. So positive divided by negative will still result in a negative. M is equal to negative 5 over 3. The same. This demonstrates that irrespective of the order in which we place the numbers, the same answer will result. This is, however, not without adhering to the formula in which the ones have to be vertically aligned and the twos have to be vertically aligned like this. So the twos are there, the ones are over here. If the ones are over here, then the twos are over there. If we crisscross it, we are in problem. As long as there is no crisscrossing, then everything is okay. When I say crisscross, I mean that the ones and twos are not vertically aligned. So if we have a situation like this where the twos are like this and the ones are like that, we are sure that the answer will not be correct. And if we have the ones like this and the twos like this, also the answer will not be correct. But as long as we have them vertically aligned like so, 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 and so, then we are sure that we are always going to get the correct answer. Such a situation will always give the incorrect answer, this one that we have right here, when attempting to find the gradient of a straight line. The volume of a cube which has edges of 10 centimeters is what we are attempting to find in this particular problem. A cube may be classified as a rectangular prism or cuboid. Its volume is given by V is equal to length times width times height. A cube is special because all of its edges are equal. The length is equal to the width is equal to the height. In this particular case, each one of them is equal to 10 centimeters. So let us put 10 centimeters right there for the length, width, and height. And also, we do that for the formula. The volume therefore becomes V is equal to 10 multiplied by 10 multiplied by 10. No doubt that is 1,000 centimeters cube. That is represented by option D. The correct answer is option D. Let us take another go at the solution of the problem. We may also say that the other sides are equal to the length since all edges are equal. So put length for each one of those. The volume therefore becomes V is equal to L multiplied by L multiplied by L, which is 3 occurrences of L multiplying together, and that will give us L cubed. So V is equal to 10 cubed. When we cube 10, we get a 1 followed by 3 zeros, and that is 1,000 centimeters cubed. In finding the volume of a cube on a speed, it is appropriate to just cube the length of one edge. So if we have a cube and we need to find its volume, cube the length of one edge and we are done. How many kilometers will a car travel in T hours at a rate of V kilometers per hour? The solution of this problem is dependent on the knowledge of the simple and popular principle that the distance traveled by a particle is equal to the product of the speed and the time taken. The time taken is equal to t and the speed is v. What else is there to it? Distance is equal to speed multiplied by time. Substitute those v and t. Distance is equal to v times t. The multiplication sign is not necessary. V multiplied by t is equal to Vt, and that is option A. Multiplication is commutative. The order in which we multiply numbers, terms, or expressions does not matter, and therefore does not affect the result. So Tv is equal to Vt. It doesn't matter. The correct answer is option A. The figure, not drawn to scale, shows a sector of a circle center O. the length of the minor arc PQ is 8 centimeters. What is the length of the circumference of the circle? And what do we know? We may begin by using simple common sense and reasoning. As a reminder, let us show that the length of the arc is actually 8 centimeters as stated in the statement of the problem. That arc is associated with 60 degrees, which is 1/6 of the angle associated with an entire revolution. So if this were a circle, then this arc would have been 1/6 of the entire circumference of the circle, because the angle associated with this arc is 60 degrees. The angle associated with the entire circle is 360 degrees. 60 is 1/6 of 360, so this is 1/6. If this is 1/6, what do we know? Therefore, 8 centimeters represents 1/6 of the entire circumference of the circle. Consequently, the entire circumference is 6 multiplied by 8 centimeters, which is equal to 48 centimeters. The correct answer is option C. On the next slide, we will use our knowledge of mensuration coupled with algebra in order to arrive at a more mathematically encoded answer. There we have the problem again. We may use a formula for the length of an arc and equate it to 8 centimeters. So, arc length, theta over 360 multiplied by the circumference is equal to 8. So the fraction of the circumference that the arc represents is multiplied by the circumference, and the result is 8. But we have some more information. Theta is the angle associated with the arc. 2 pi r is the circumference of the circle that we are attempting to find. 360 degrees is the angle of one revolution, and on the other side we have the length of the arc, which is 8 centimeters. In this particular case, theta is equal to 60 degrees. So replace theta with 60 degrees and everything else remains the same. Now this fraction is 1/6. The fraction may be reduced to 1/6. So we will have then 1/6 multiplied by 2 pi r is equal to 8. The expression may be written without any adjustment to 2 pi r because it represents the circumference of the circle, and we are attempting to find the circumference of the circle. So leave 2 pi r alone and make other adjustments, because we are attempting to find the circumference of the circle, and 2 pi r is the formula for the circumference of the circle. So the expression may be rewritten without any adjustment to 2 pi r because it represents the circumference of the circle that we are attempting to find. (2 pi r over 6). The circumference divided by 6. By eliminating the denominator, which is 6, from the left hand side, we may find the value of 2 pi r. The effect of this is that 6 is multiplied on the right hand side. So 2 pi r is equal to 8 multiplied by 6, and that is equal to 48 as we had before. So 2 pi r over 6 is equal to 8. Eliminate 6 in the denominator by multiplying through the equation by 6. In that way, 6 is eliminated from the left hand side, and on the right hand side we will have 8 multiplied by 6, which is equal to 48. We have confirmed that the correct answer is actually option C. The distance around the edge of a circular pond is 88 meters. The radius in meters is what we are attempting to find. So let us find an expression for the radius of the circle. The pond is circular. This means that the distance around it is equal to its circumference. Its circumference is given and we need to find its radius. Let us use the formula of the circumference of a circle and equate it to 88. We know the circumference of a circle, the formula of it we have just used on the previous slide. So no doubt 2 pi r is equal to 88. We now need to make r the subject of the formula. It is accompanied by 2 pi on the left hand side in a multiplication relationship. Dividing the equation by 2 pi will cause 2 pi to be eliminated from the left hand side, and on the right hand side we will have 88 divided by 2 pi. So r is 88 divided by 2 pi, and we need not reduce this or write it in any other way because we have the option right here that is exactly like that. So r is equal to 88 over 2 pi, and that is represented by option D. Eliminating the 2 pi here, we will be able to say r is equal to something. Because we need r on the left hand side, we need to eliminate this 2 pi by dividing by 2 pi throughout the entire equation. The 2 pi is eliminated from the left hand side, and on the right hand side we have 88 divided by 2 pi. The correct answer is option D. I am always delighted to see a problem like this. Students are sometimes programmed to use formulae in a slavish way. I prefer to see them used in a variety of ways. Knowing a formula is not enough. I always emphasize the importance of being able to transpose a formula. That will cause candidates to be more flexible. On leaving Trinidad, the time on the pilot's watch was 2300 hours. When he arrived at his destination in the same time zone, the next day, his watch showed 300 hours. How many hours did the flight take? The only difficulty in this problem is that time goes over into another day. On the 24-hour clock, the 24th hour is represented by the 0th hour, or the 0th hour, or hour 0. In this problem, we will still represent it as 24 hours, or 2400 hours. There we have it. We may think of the given period of time in two stages. The stage leading up to midnight, which is up to 2400 hours, which is the same as 0 hours, and the time after midnight. The time leading up to midnight may be found by subtracting the initial time from the time representation of midnight. So let us subtract from this time representation of midnight. We are attempting to find the time up to midnight. So we are subtracting the initial time from the time representation of midnight. And we get what? 100 hour. The time after midnight may be found by a similar calculation in which we subtract the time associated with midnight from the final time. So the time associated with midnight we subtract from the final time, and we get 3 hours. So in the first stage we have 1 hour, in the other stage we have 3 hours. Combining the two periods of time, we have 1 hour plus 3 hours, and that is equal to 4 hours. The correct answer is therefore option A. Same problem. The problem may have been solved mentally by a candidate who realized that the time went over into another day. So the time went over into another day. From 2300, typically 11 to midnight, typically 12 o'clock, is 1 hour. From midnight to 3 a.m. is 3 hours. This gives us a total time of 4 hours. An aircraft leaves A at 1600 hours and arrives at B at 1930 hours. The same day, traveling at an average speed of 550 kilometers per hour. A and B are in the same time zone. The distance from A to B in kilometers is about, and it's just a matter of solving the same problem that we have just solved, but we need to work out the time, or to be more considerate in arriving at the time. The distance is equal to the speed multiplied by time, as mentioned on a very recent slide. Let us first find the duration of the flight by subtracting the final time from the initial time. There we will get 3 hours and a half. 3 hours and 30 minutes. The first two options are obviously incorrect. My first guess is option D, because 1815, which is 1815, seems to be too close to 15 for the answer to be correct. So we are attempting to multiply 3 and a half by 550 in order to arrive at the answer. So 550 we have there multiplied by 3.5. So 3 5s 15. Well, we imagine that since we are multiplying more than 5 in this particular case, because we have an additional values here by more than 3, then the answer is more than 15. But how much more? I'm saying that 18 seems to be too close, but let us see if it is actually the truth. Let us begin our rough calculation by saying 5.5 multiplied by 3 is equal to 16.5. So that is what we are doing first. We are multiplying 5.5. We are not taking the entire 550. We are just saying 5.5, just to have an idea of what the digits will look like, because obviously the digits will be different in every single case. So if we arrive at the digits, then the magnitude of the value might not be so instrumental. So let us see if we can arrive at the digits that are present in the option. So let us say 5.5 multiplied by 3, that is 16.5. And also 3 multiplied by 5 is equal to 15, and a half of 3 is 1.5. That's how we do it. So it's 5.5 times 3. So 3 times 5 is 15, and a half of 3 is 1.5. So add 15 to 1.5, we get 16.5. No problem seeing that multiplying 5.5 by 3 is actually equal to 16. But we are not multiplying by 3, we are multiplying by 3.5. So we need to take 0.5 of this, which is 5.5, or a half of 5.5. So there we have the first part is 16.5. We now need to add a half of 5.5 to 16.5. A half of 5.5 is 2.75. A half of 5 is 2.5, and a half of a half is 0.25. Combining them, we get 2.5 plus 0.25, which is 2.75. When we add those together, we get 19.25, so we are sure that D is our correct answer. And the student should attempt to multiply in your mind by sectionalizing the numbers into convenient sections and multiplying them. So we are saying if we are multiplying 5.5 by, we have it, 5.5, although we are not just saying 5.5, we know that we have 550, but we are just working at the digits and not the magnitude of the number in general. So if we say 5.5 to be multiplied by 3.5, that is what we have. So we should first take 5.5 and multiply that by 3. So in so doing, we multiply 3 by 5.5 and we get 16.5. But do not forget that we have the half. So a half multiplied by 5.5 is our next stop. So multiply a half by 5.5. In multiplying a half by 5.5, what do we do? So we need to add a half of 5.5 to 16.5. We have the 16.5 here, no problem. But we need to add a half of 5.5 to it. How do we find a half of 5.5? Well, we could just divide it by 2 in our minds and we will get 2.75. Or we may say a half of 5 is 2.5 and a half of 0.5 is 0.25. So 2.5 plus 0.25 will give us 2.75. There. And we add the 2.75 to that and we get 19.25. Now this seems like more than a mouthful, but if we are sharp on the manipulation of digits, then this can be done at the snap of a finger. The correct answer is option D. That was a nice exercise in mental arithmetic. You seem to have enjoyed it a lot. I enjoyed it too. One should be able to look at the multiplication problems and determine the correct answer, and the quick mental calculations can confirm it. Also, take advantage of the fact that in a multiple choice problem, the correct answer is always there already. So we are not just working in order to determine a correct answer. Sometimes we are working in order to identify the correct answer that we know is there already. So that mental gymnastic or mental arithmetic that we have just done is somewhat enjoyable. It can be if we practice doing that all the time. Do not forget that in a multiple choice problem or multiple choice examination, we cannot use a calculator.